Okay, this video is on what are called finite geometric series. All right, so let's kind of break down the title here first. Finite, what that means is there is a distinct beginning and end. So it might be, I want to add together 5 terms or something like that. A series means a sum, so we're going to add things together. So our objective for today is how do I find the sum of a finite geometric series? As I've been telling you guys all along as we've been doing these sequences and series, I would highly, highly, highly recommend you make yourself, you can call it whatever you want, but a little cheat sheet that you can keep right next to you that has the arithmetic sequence, the arithmetic series, the geometric sequence, and the geometric series formulas right next to you, so they're easily at your disposal. In order to find a geometric series that is finite, next lesson we're going to talk about what do you do when it's infinite. All right, we're going to use this formula that says S sub n, so the sum, is equal to a sub 1 times 1 minus r to the n over 1 minus r. And I always like to think of this denominator as always having parentheses around it as well. Now, off to the side here, just in case we need it, let's make sure that we remember the geometric sequence formula. All right, I'm going to write that in here. That's a sub n is equal to a sub 1 times r to the n minus 1. All right, we may need that because remember, we have to identify what a sub 1 is. Remember, that's your first term. We have to be able to determine R, and that's your common ratio. And we have to know N, which is the number of terms. Right there it even says it. I guess they all say that in the key concept there. All right, so we got to apply this formula. All right, so here we go. First thing, I know in order to do these problems, I need to use the formula that says the sum of the series is going to be a sub 1 times 1 minus r to the n over 1 minus r. All right, I know a sub 1, I know r, and I know n, so I'm simply ready to go into the formula. All right, I'm going to find s sub 8, because there's 8 terms in this series. All right, my a sub 1 is negative 2. Multiply that times 1 minus r to the nth. So 1 minus 2 to the 8th divided by 1 minus r, which would be 1 minus 2. All right. Now, as I've told you guys numerous times, I don't trust the calculator. So I'm going to make sure that I'm following the order of operations when I go to simplify this. All right. Some of you guys are more confident than I am with a calculator, and that's okay. All right. So the way that I'm going to look at this is I'm going to first figure out what is inside of each of the parentheses. So I'm going to take 1 minus 2 to the 8th, and that's negative 255. All right. So I have negative 2 times negative 255, and in the denominator 1 minus 2 would give me negative 1. I'm then going to grab that calculator, take negative 255 times negative 2, get that answer, divide that by negative 1, and I get that the sum is negative 510. Simple as that. Like I said, some of you guys may do it faster on the calculator. I like to do it in steps there. All right. So let's take a look at this next one. All right. Remember, what are the pieces that we need? We need a sub 1. Got it. We need r. Got it. And we need n. Do we know n? Well, in fact, we actually do know n. All right, it's kind of hidden in there though, isn't it? So it's a sub 8, so I'm thinking that's the 8th term, right? Well, you know, there's a couple of different ways to go about this. So I'm thinking it's the eighth term. But I do know there's this thing called a geometric sequence. In a geometric sequence, here's what I know to be true. I know that a sub n, or in this case a sub 8, negative 8748, is equal to a sub 1, 4, times r, we know r, negative 3, to the n minus 1 power. So I'm thinking, remember, I thought that n was 8. Let's just make sure it is. So I'm going to grab my calculator here. I'm going to take 8748, make that negative, and I'm going to divide that by 4. And that gives me negative 2187. Now, I believe that negative 2187, let me write that down, is going to be negative 3 to some power. All right? So I'm thinking, well, let's see. What if I take negative 3 and I raise it to the 8th? Well, that didn't work. That's not negative 2187. All right? So how about, what if I take negative 3 and raise it to the 7th power? There we go. So I'm going to rewrite this as negative 3 to the 7th is equal to negative 3 to the n minus 1. And remember, if the bases are the same, the exponents give the equation. Oh, look, we got that n was equal to 8. This would be a whole lot easier way to figure out how many terms there are. But I wanted to show you guys it can be done using the geometric sequence as well. We may need to be able to use that. But now I'm ready to go and find the sum here. So I know s sub 8, there's 8 terms, is equal to a sub 1, 4, times 1 minus r, so that would be negative 3 to the 8th, that's our n, divided by 1 minus, sorry, I have bad lighting today, so it's hard to see my pen. I have 1 minus r, which again was negative 3. All right? So I'm going to clean this up. S of 8 is equal to 4 times, let's see. Be careful here. That doesn't say 1 plus 3 to the 8th. It's saying 1 minus, and then we got to take 3, make it negative, raise it to the 8th. And that gives me negative 6560. We're going to divide that by 4. Well, this arithmetic's pretty easy. S of 8 then would be negative 6560. The sum of those 8 terms would be negative 6560. All right? So let's take a look at this one. In order to find a geometric series, we need to know a sub 1. Got it. We need to know r. Got it. We need to know n. Don't have it this time. This is a case where I have to do the geometric sequence formula. So let's do that. All right. I know a sub n, which is negative 512, is equal to a sub 1, which is negative 4, times r, or 2, to the n minus 1. So I'm going to grab my calculator. I got negative 512 divided by negative 4, and that gives me 128. 128 is equal to 2 to the n minus 1. So I believe 128 is maybe like 2 to the 7th. Yes. So I'm going to rewrite that as 2 to the 7th is equal to 2 to the n minus 1. So the bases are the same, and I would determine that n was 8 here. There's that third piece of the puzzle to find the series now. All right, so S sub 8, those 8 terms, is going to be a sub 1, negative 4, times 1 minus r to the n, 1 minus r to the n, divided by 1 minus r. So S sub 8 is negative 4. Let's see. Grab my calculator. 1 minus 2 to the 8th is negative 255. Divided by negative 1. All right, and then to clean this up, I have negative 4 times negative 255 divided by negative 1. And obviously you could do some of this without typing everything literally in. Okay, so I get negative 1020. All right, the last scenario that we're going to look at is how do I figure out the number of terms? So how do I figure out n if I know what the sum is? So let's go ahead and fill in the formula here. We know that S sub n is negative 728. That has to equal a sub 1, which is negative 2, times 1 minus r to the n. We don't know n there. Divided by 1. Daggone, I keep messing up. Sorry. 1 minus r. Okay, so let's see what we got here. Let's clean this up a little bit. Okay, negative 728 is equal to negative 2 times 1 minus 3 to the n over negative 2. Now notice, I can't subtract that 1 minus 3 to the n because the 3 has a variable exponent. But I can simplify this a little bit. I know that those negative 2's are going to cancel each other out. So really I have negative 728 is equal to 1 minus 3 to the n. All right, so let's see here. I'm going to subtract 1, so that gives me negative 729 is equal to negative 3 to the n. I really don't want to deal with negatives, but if I think about it, I know that n's going to have to be something odd, because that's the only way I can take a negative number, raise it to that power, and get something negative. Okay, is if the power was odd. But I'm going to clean this up even more just because I feel like it. 3 to what power gives me 729? I'm going to guess here. How about 5? Let's see. Nope. Okay, so then I'm going to try, how about 3 to the 7th? Nope. How about 3 to the 6th? Yeah. Huh. So that's going to give me an even power. I was wrong in my assumption. But I do know 3 to the 6th is equal to 3 to the n. So therefore, n has to be 6. It's interesting. Let me just check something here before I tune you guys out. If I have negative 3 and I raise that to the 6, that gives me 729, and I'm supposed to have negative 729. Anyway, we know that there have to be 6 terms, though. We can't have a negative set of terms. The other way that I can double check myself is I could take that n to the 6th, or n is equal to 6, and I could come back and I could plug that into my formula to check it. I'm going to do that just for the heck of it and see if I made a mistake. So I've got 1 minus 3 to the 6th times negative 2 divided by negative 2. And that should give me negative 728, and it does. So I know I have verified, even though my thinking was off a little bit, I verified that that should equal to 6. Hope this helps. Let me know if you guys have any questions.